Hi, my name is Zoya, and I'm a participant in this year's LIYSF program. And today we have the wonderful opportunity to welcome Sir Professor David MacMillan to the Imperial College in London campus. How are you today?
Hi Zoya, how are you?
I'm great. Are you excited to be here?
Unbelievably excited. It's really a remarkable get-together of people from literally all over the world who are really excited about science and just the chance to even just socially connect with people and talk about what they're doing. It's fantastic.
Yeah. So you were awarded the Nobel Prize in Chemistry in 2021 for your work on organocatalysis. What is organocatalysis in a nutshell?
In a nutshell, organocatalysis is basically the idea, if you think about catalysis, takes care of or works for literally so many chemical reactions that we care about in the world. And chemical reactions are literally everywhere, all around us, in our body, all the time. But organocatalysis is a new type of catalysis that instead of using traditionally metals, it uses organic molecules. And much like you and I are made of organic material, organic catalysis is used in catalysts that are made from organic molecules. What's really great about that is it's completely sustainable, it's incredibly abundant, it's really inexpensive. And it means that not only is it good for basically the planet, but it also means that everyone around the planet can actually work on it because it really doesn't cost very much money to do that type of science.
Yeah, definitely. And you've often stated that science is a collaborative effort. So looking forward in the near future, and how do you see organic chemistry and the new organocatalysis helping tackle global challenges such as climate change, energy, and healthcare through collaboration?
Yeah, so climate change and sustainability is going to be all about catalysis. If we could do any catalytic reaction we wanted tomorrow, we could solve climate change tonight, we could change the energy problem tonight, we could overcome sustainability instantly. So catalysis is incredibly central. The problem is we don't have those types of catalysts yet. So when I think of the future, what we're doing, what everyone else is trying to do, is to invent these types of catalysts that will allow you to do that. We're using organic catalysis as a launching point to do that. We're also using light, or what's known as photocatalysis, to do that too. But it's really critical for the world and critical for science that we develop these new types of catalysts.
So it's the future, basically.
I would say so, yeah.
It's lovely. So what piece of advice would you give to young scientists who feel a little bit pressured maybe to specialize early, especially if they're interested in multiple disciplines?
Don't specialize early if you don't want to specialize early. I just gave a presentation where I talked about I went to university to do physics, and I was terrible at physics. But very fortunately, I found organic chemistry. And I talk to everyone I know, and especially my children, and say, when you get a chance, sample different areas. Learn about as many different areas as you can. And when you're really excited about something, you'll know it. Because you won't feel like you're doing it because you have to. You'll feel like you're doing it because you want to.
Yeah.
And that is really tapping into your own motivations. So sample as much as you can. Find the thing that you're passionate about just inherently, and then it's just downhill skiing from there. It's so much fun getting involved with great science that you're just intrinsically curious about.
Okay, yeah. And throughout your journey, what would you say was the most significant discovery you've had, and if it shaped your scientific thinking in a different way?
The biggest scientific discovery that I've had along the way is actually nothing to do with what we won the Nobel Prize for. It was basically learning about, there's these catalysts that you can shine light onto. And when you shine light onto them, they will absorb that light in the presence of all other molecules and become basically 32,000 degrees Celsius, while everything else is at room temperature. With those catalysts, you can do so many different things. And we've been working on that, but now there's literally hundreds of researchers all over the world doing the same thing. It was an extraordinarily great thing to be associated with, to be involved with, especially from the ground floor. But every day there's completely new things coming from it. It's the gift that keeps on giving. And it's now in biology, it's in chemistry, people are taking it into like physical and physics sides of things too. So it's an extremely exciting area of research.
Yeah, and beyond your own research, is there something that excites or inspires you, whether it's in science or something completely beyond the lab?
What excites and inspires me is every single time as a scientist who's been around for a while, that you suddenly think, well, maybe we're getting to the limits of what we know. And then this new generation of young people come through, and all of a sudden, all these new things start showing up. And you realize that science is evergreen. Science we've only scratched the surface of what we can actually learn. So what's most exciting to me is like when you literally can open up a journal and see all the new things that are happening. It's a bit like when you first found out about an iPhone. or you first found out about the internet, or you first found out about these new technologies that blow your mind, imagine that you could open up on a journal and see all these new pieces of science happening all the time. It's mind-blowing. It's exciting to see all those new things and imagine what the future is going to be based on all this new science. So it's an incredibly exciting time right now.
Well, thank you so much for talking with us today, Dr. MacMillan. This was a lovely opportunity, and I'm sure everybody here was just as excited to hear you speak. And thank you so much for joining us here today.
Thank you, Zoya.
Thank you.
Thank you.